In this lesson, we're looking at the additional properties of binomial probabilities. So, first of all, let's go ahead and say you're going to flip a coin 100 times. How many? Most of you are going to say 50, and you'd be right. How did you get 50? Well, you said, well, I've got 100 flips, and a half, or 0.5 of them, will be. So this is, let's remember what this is from our last lesson. That's n, the number of tries or trials, and that's p, the probability of success, right? Now, if I was trying to graph this, how would I do that? So let me go ahead. I could have 0 heads out of 100 flips all the way up to 100 heads out of 100 flips, right? But most of the time I expect to be around 50. So the peak of my distribution will be right there and kind of around that. Okay? Let's say we have an unfair coin, someone's trying to jip you, and it lands on heads only 20% of the time, because they know you're going to bet on heads. And we're going to do 100 flips. How many heads would you expect? Let me write that down, 100 flips. Well, most of you will say 20. How did you get that? That's 100, which is your n, times 0.2, which is the probability of heads for this problem. And if I were to draw a distribution for that, there's 25, so 20 is about there. I would expect the peak to be at 20, with roughly half the data over here and half the data kind of spread out and off to the left. So the 50 would be way over here, the 20 would be here, right? Now let's say we have a different unfair coin that lands on heads 90% of the time. This is probably becoming old hat for you. Oh yeah, it's 100 is n, and this time the probability of heads is 0.9. Okay? And if I were to draw that from 0 to 100, you would expect the peak to be way over here on 90, and then just kind of almost never do you get 0 heads on this coin, because you're going to flip it 100 times. Most of the time you're going to get heads. So you probably noticed, what were we doing? We're multiplying n times p, n times p. All of these are expected values, how many heads you would expect, right? And the symbol for that is mu, right there. A mu looks like an M and a U had a baby, all right? It looks like this, so you start an M, then do a U, and start it out, so it looks kind of between a U and an M, all right? And you pronounce it mu, like a little kitten, all right? So our formula that you'll be using on these lessons for today for expected value is mu equals n, the number of trials times the probability. Now, here, these kind of look like the graphs I was drawing. So if you were to try to match up, where does the 0.2, 0.5, and 0.9 go? This is 0.5. It looks most like this one up on top, right? And we call this one symmetric. If you say, oh, what beautiful symmetry, you can cut it in half and it looks the same on both sides. So if you have a question on your assignment today and it says, the distribution is symmetric, what's the probability? Big hint, there's your answer. You just assume it's 0.5 if it's nice and symmetric and mound-shaped in the center. Which one does this one look most like? My 0.2 or my point? Hopefully you say it looks most like my 0.2. So P is 0.2, and I do want to know what the skew is. Now you're probably a little bit rusty, some of you still remember. The skew is where the tail goes off. So it's like the slide is aimed at. This one is aimed to the right. So this is skewed right. The big pile is on the side of the skew. This one is skewed left. And you can tell the p-value is really high for this one because it's almost off the edge. And in fact, the p-value is 0.9. Okay. There's also a shortcut for determining a calculation for standard deviation. What is standard deviation? A way to measure spread, all right? So that's spread. And the formula is sigma equals the square root of n times p times q. So circle that puppy, you want that. If you're doing a 3x5 card to use for your test, I would strongly recommend writing that on there. So let's go ahead and look at this example. A statistic's 20 multiple choice questions with 5 answers for each question. If students did not study, heaven forbid that would happen, and randomly guessed on all their questions, what is the expected, and let's say, number correct on the test? And also, what is the standard deviation? So part 1, let's write down what we know. We know that n is 20, because we're going to try 20 times, 20 different questions. The probability that one question is right is 1 out of 5, because only one answer out of 5 is correct. I can change that to a decimal, which is 0.2. Q, which will come in handy today, is 1 minus 0.2, so that's 0.80. All right, pretend that's a decimal there. And if I'm trying to find the expected value, mu equals n times p, so it's 20 times 0.2, which is 4. My standard deviation, this symbol, the nickname for this, whatever, is sigma, or lowercase sigma. We also call it standard deviation. It's the square root of npq, just like we said before. N is, did I say 20? Yes, 20 times 0.2 times 0.8. Multiply all that, take the square root, and you're going to get about 1.789. All right?